Good morning, good afternoon, good evening, and yeah, welcome to our webinar on safe data for agents. We are just waiting for like a few more, 1 or 2 more minutes. People are still trickling in, and then we'll kick off. In the meantime, we are just interested, like, where are you currently in your journey with AI, with Gen AI and data? So really curious to learn about where you are, what you want to learn from this webinar. So just use the comment function with the chat.
Yeah, so the idea is
Mm,
if you have it in
mm,
production, one,
mm,
if you're doing
mm,
POCs and pilots, but not in
mm,
production, not operational,
mm.
two, if you're just using for developer productivity, engineer productivity, for personal on the side, but it's not really in the enterprise, that's three. I couldn't think of more, but I put four if you're in a different category, put four. We are going to talk about safety for AI in enterprise, which is mostly for people who are trying to transition from two to one mostly, or starting with two. That's where we are.
All right. I would say we're slowly approaching quorum. Sina, would you be ready?
No one wants to tell us
Mm,
where they are in
yeah.
their journey. There's nothing. Oh, maybe I don't
Yeah.
see
We
it.
we we
Oh,
we see the first questions
ah,
coming up.
I
Yeah.
just see where they
Yeah.
went.
Yeah.
Gotcha.
Cool.
That section.
Uh, Otherwise, yeah, welcome again to our webinar on safe data for agents. All right, 2 weeks ago, we had another webinar on kind of like bridging this AI data gap. We got a lot of questions for this one particular topic around like safe data consumption by agents. And I think Sina is actually stepping in here and trying to give us a deep dive on this topic. Maybe just a few housekeeping items. If you have any questions throughout the chat, just use the Q&A function if you're joining via Zoom. If you're on YouTube or LinkedIn Live, just write in the comments. I think, Sina, you'll try to answer most of the questions during the talk at each section, but we'll also have some time reserved in the end. And I think then we'll share the recording probably tonight or tomorrow Pacific time. So if you want to get more detail, rewatch it, there will be a follow-up email being shared. With that, Sina, thanks so much, and over to you.
Awesome. Thank you, York. Welcome everyone to this safety talk. My name is Sina Jahan. My background is in an engineer. I spent many years at ThoughtWorks, which if you are not familiar with, it's a global technology consulting firm. When you work for many years there, the thing that you get good at is enterprise software, enterprise teams, and how to do that. I spent a lot of years in telco and banking and healthcare. It's like a crash course in enterprise, and I led different data teams and trying to make data teams better and more productive. Most of that work kind of manifested itself in data mesh movement and data mesh architecture. And now I'm doing head of product engineering at Nextdata, which means working with customers that are on the journey of adopting data products and making sure we're building the right thing. The talk for today, you probably have seen the title and the subtitle, but we're going to talk about data, serving safe data for AI. We're going to talk about why does this matter, why you should care, I'm assuming most of you are data teams, or as a practitioner, or as a team lead, or as a platform engineer, or you're building your internal, why does it matter? We're going to talk about three problems that we think are worth solving for and what our opinions are about it, and then we're going to get to Q&A. So why does this matter? There is a rise in amount of investments that we see in the AI, plus high risk of failure. So the two sides of this coin. This is not should be surprising to anyone if you are reading news or following anything. This is a screenshot from Accenture's website. 80+% increase in amount of investment. This is a survey from the C-suite. Um, and 80+% also increase year over year. So these are the people who did something in 2024 they got strong signals and they're now investing even more in it in 2025. Even if you don't believe all these numbers and you think these are hyped up a bit, of course, Accenture might be biased in these numbers. Even if you think, if you're cynical about it and you say maybe 20% of this is true, that is still a huge amount of new investment that's going into this direction. So that's one side of the story. The other side of the story is these kind of scary stories that you hear once in a while when the AI coding tool is wiping production databases and trying to cover its tracks, or new data leaks because of the new attack surface that has now opened up because of AI. And when the same companies surveyed the executives, you get about the risks of AI, risk of going to production with AI, risk of going to beyond pilots with AI. You get this kind of data around that the number one risk from their point of view is all about privacy, governance, security, reliability. And that's what this talk about. This talk is not about how to do bias and ethics of AI. This is more around privacy and security of a data that gets served to AI for either classic ML or the new Gen AI applications. So comparing these two sides of more investments plus higher risk, the vibe in the executive rooms are that there's a low tolerance for slow-moving data teams. As a data team, you have to be on your toes, you have to move faster, and which means just to do a homage to Facebook early days when they said like move fast and break things. It's like a move fast but don't break things. A speed with safety, like this kind of contradictory things together, seemingly contradictory. That's what we are thinking. We think there are ways to achieve both. So if that's the why, let's talk about what. What are we gonna do about this? This webinar has three parts. We are gonna talk about quality and how to enforce it. We're gonna talk about compliance, especially in the federated governance scenarios. And then we are gonna talk about containing and lowering, managing complexity. Let's start with the first one, the enforcing of quality. If you have been following our work or Jörg's webinar or any of the things that we have published over the past couple of years, our company, Nextdata, we have created a platform for building, managing, observing data products. Data products are these autonomous services that have data sensors that react to input data. This can be from structured data, unstructured data, APIs, data that you have from operational applications. They use compute and storage services as infrastructure, and they serve data to different consumers. It might be BI, ML, or other applications. There's a couple of new boxes on this picture, if you have noticed. One is the rise of unstructured data with AI on the left side. That's a completely new thing which we're going to talk about. It used to be there, but not to the extent that we're seeing it right now. And then on the right side, things have also changed. There used to be BI and ML and applications, and ML is now called classic ML. And the agents is a new box, which is one of the biggest consumers of data products. So when we talk about enforcing quality here, the first area that we think is worth paying attention to is the area when a data product is serving data to the consumers. We have probably heard about data contracts and enforcing quality contracts in that interaction place. And we call contracts that you are promising to your consumer as a product producer, we call them promises. So these are the things that you're promising to your consumer. And we have created enough lifecycle management, which is very, very opinionated about how a data product lifecycle should act when it's transforming the data and serving data with these promises. Promises are domain specific. They are specific to your business and the domain of that they're being created, but the framework and the lifecycle has opinions around it. You can see an example here. So as a producer, I'm promising that this data that I'm serving to you has these kind of checks and balances. This is a great place for data quality rules or completeness rules, freshness rules, drift rules. And as a promise definition, there are different consequences that you can specify for these promises as the contract. You can say pass and warning, just send me a warning if I'm not in that criteria, or fail, which fail or quarantine means I'm not going to push this data forward. So that data is going to get contained. This is the part that when I was mentioning that it is opinionated around how to manage the life cycle. This is the part that I meant. This top part is your kitchen, is your domain. It's domain specific. But the bottom part around the workflow is where it comes to play, especially before this data gets promoted. So what does that mean? We have talked about the data product being multimodal. If you come to York's webinar a couple of weeks ago, a data product can serve as SQL or as object store for as Parquet files. These are what we call different output ports. We only promote the data to those output ports if these promises pass. As a result, we can ensure that the data that's going to BI or ML, or now to your agents and to your MCPs and to your RAGs from vector embeddings, these are all have passed all these quality checks. Let's look at an example of this in real life. So I'm looking at a data product. A data product has owners, has information about when was last run, what kind of compute and storage services it's using. It also has information about semantic models. And this sales data product from a fictional enterprise has a set of output ports. It has outputs on Snowflake, it has outputs on ADLS, and it has a set of promises. These promises, as you can see, they're Python code and schema code, are things that the producer is providing, think of as a SLA. These are the SLAs that I'm promising to my downstream consumers. If data is available here in any of these ports for the consumer, as a consumer, if you want to go and request access to it, you can be ensured that these have passed these promises. And these promises, you can use your own tools. We have integrations with Great Expectations, Soda, or you can just be plain Python. In this example, these are plain Python code that are domain specific for this sales domain data product. So that's one way, one angle of enforcing quality. There's also a flip side to that. Like if you think about data coming in, if you go back to this picture, you can also think about another area to enforce quality on when data is coming in, which is the expectations. So this is the other side of the story. You can say, as data is coming in, if it doesn't match this kind of criteria, don't even go through the transformation, don't even materialize this data, because something upstream is wrong, and you still have the same consequences. You can say stop it or quarantine it, or some human manual intervention is required, send integrations to different observability tools or PagerDuty tools to get notification about something is wrong on upstream. And the combination of these two things together, the combination of promises as data going out and expectation as coming in, we found is a very, very powerful balance between the tools that we used to have and this new concept. If I want to summarize data testing and data observability and how is this a little bit different, you can think of it like this. We have had data testing for a long time. I used to write Great Expectation code many years ago, but usually you're one step behind. You'd write a test. They're very good. I'm not bashing data testing. It's more like the things that always surprise you is the thing that you didn't think about. There's yet another thing that you should have a test for, because you can't really predict how the data is going to get used. And that kind of got birth to the idea of data observability, which basically they said, yeah, maybe we shouldn't write tests. Maybe we shouldn't rely too much on testing. Maybe we should just throw some ML at it, look at anomaly detection, look at the pattern of a data. And if something changes, then we will raise it as a quality concern, which is very good and it has its own place. It's also very reactive. Like if you look at the ecosystem of data observability and where it gets plugged in the enterprises, it's usually around, okay, something bad happened. I'm going to send it to Slack. I'm going to send it to PagerDuty. Escalation policies. Someone should come and do something about it. The bad data has already landed. Versus what data contracts do, they're trying to balance these two situations. Of course, you have to write tests. These are the SLAs that you're providing. But because data products manage their own orchestration, and there is a life cycle to the data product, we can really enforce that promotion. So coming back to this slide, if that is not passing that quality, that data even doesn't get promoted to the output. Stays as the private storage of a data product, and no one other than the owner can even see that data or play around with that data. It's only for debugging purposes. So you can kind of catch it before it escapes the system. We didn't build this for agents, obviously. We built this before even agents were a thing. But as this rise of Gen AI and LLMs, keep hearing this kind of quotes about what about unstructured data? What about all the images and all the scans and all the PDFs? And I probably heard this number of like 90% of enterprise data is unstructured, and it's very minimally used in enterprise data because there was no case for it. Um, the interesting thing about creating a logical boundary on top of compute and storage, if I go back to this slide, it doesn't really care about, because it's not bound to technology. It's not, it doesn't really differentiate between structured and unstructured. It is a unified interface between both of them. So when we were looking at this data product, as the example, so imagine this is sales information. It has products and sales transactions and typical things, but you can also think of, if you need to serve unstructured data, you will need to consume unstructured data or produce unstructured data. The same concepts apply. So you can have inputs to object stores or to Google Drive or to your Confluence that get information as unstructured. Use whatever tools you want to use to make it structured, or serve as raw. So because sometimes you actually need the actual raw data for your output as the boundary of the same product. So it's because of the logical abstraction, you kind of combine them together. And as a result of that, all of the same concept that we just talked about promises and SLAs and ensuring that the data quality is up to the standard, they all still apply even on the unstructured data. The other thing that we have noticed is, so we created this DSLs for defining these data products. So this multi-channel sales is an example of a data product. If I go to the code of this, we defined a domain-specific language to make the definition of this easier. Why did we do this? We did this because our whole thing was move the ownership to the domains. This should not be something that is only owned by centralized platform teams. So it's a very simple to understand DSL. You're looking at the Python version of it. There's a YAML version of it too. You define inputs, you define transformation, you define outputs as Lego blocks, and the domain teams, depending on their maturity, they can put them together and create these data products. And it was interesting find that where you do define, when you put effort in defining a simple DSL, LLMs are also very good at generating these things. So the question had to be asked, like, can we actually wipe code our contracts now? And we can take it for a spin. It actually turns out they're pretty good at doing that. So if I'm gonna go to, um, I'm gonna use Cloud Code, which if you're not using Cloud Code, take a look at it. It's a MCP client, and it's very good. It uses a bunch of very good models on the back end for generating code. We have shipped up MCP, which is a model context protocol server, which understands our applications very well. So this instance is already configured with the Nextdata MCP. which if you look at the tools, it knows how to interact with the mesh. It knows how to understand the mesh, how to register it, how to launch data product, how to get the source code, how to get the test. It has these kind of services. And as a result, if you can ask questions like this, like look at the downstream products of multi-channel sales, look at their expectation, and based on those, suggest a new promise and add it to the spec. And if we let this run, it will take 5 to 6 minutes to go through a different scenario. And I ran it right before this call. Um, it's it will look at the downstream products that are using this product. It finds, for example, the sales value is an example of that. Looks at the expectations, look at the transformation code, look at the usage patterns, and based on those, suggest, okay, you need a semantic model enforcement. So if the schema changes, they need to know because they're clearly in their queries are depending on semantic information. And there are some encryption and linking that you should also enforce as parts of your data product. Is it 100% there? Probably not. You still need a human in the loop to kind of review this code and make sure it's all good. It sometimes makes mistakes, especially in production scenarios where the downstream queries can be a Databricks bundle, asset bundle or a Snowflake complex query. However, it's a good starting point. Like it can give you, if you look at what's actually happening, it kind of generates these kind of promises based on these boxes downstream. Usage patterns, transformation code, static analysis, expectations that are defined by human, and it gives you somewhere between a data testing and observability. Like it gives you some crutch to get it started, so that you don't have to start from a blank canvas, because writing tests on a blank canvas is actually a bit daunting and hard to start. That was what we had around the first item, which was how to enforce quality. And you might wonder that if you have been on platform teams and you have to manage platform that hundreds of, not even hundreds, 20, 30 of domains are using, and you're trying to get out of the business of managing domains, you want to just get on the self-service platform and let the domains manage their own data. You might wonder, okay, this is all good, but this all depends on the person who created this data product to be a good citizen and provide a good product, which is a bit of a wishful thinking. Like, of course, everyone wants to do the right thing, but everyone is also busy. The teams are small. There are other priorities. People usually, it's hard to think about all these different SLAs that you need to enforce. We call them data products. It's supposed to be like a product oriented, but in the enterprise, it's a bit hard to actually incentivize and enforce, which kind of brings us to the second problem, which is how do you enforce quality? How do you enforce compliance? This is the second part of this talk, which we have talked about this idea of global policies. If you are coming here from a data mesh universe, there was one whole pillar around federated computational governance. I'm not going to bore you with different governance models, but most of the people who are in the decentralized data and they are on different stacks, on different domains, and different part of the organization because of merger acquisition or because of the growth of the business, they cannot scale on central governance. They need some sort of federated, which means they're not confederated, they're still federated. There's still some global policy that gets applied to them, but it gets defined at the global level, but gets enforced at the local level. This has been one of the biggest area that we're excited about, because no other tool actually approaches this way. I was looking at the compliance tooling in the ecosystem. There's a lot of tools around access management, of how to access governance. There's a lot of tools around policy management, which surprisingly, most of them, if you're talking at the enterprise policy level, they are open to interpretation. They provide documentation about GDPR or data retention, and then they leave it to the platform teams, probably you guys on this call, to kind of think about it and interpret what it means for your organization, and then apply it to your scenario. We think there is a space here that's worth solving for. And I want you all to meet this new thing that we are shipping, which is um, definition of global policies. So let's go through an example with the lens of uh, stopping PII data from going to LLM. This is a very common case that we see. There are different approaches to solve no PII to LLMs. There are network security endpoints, for example, that catch you at the very end. But imagine we want to shift left and we want to catch these kind of things at the part of the life cycle and supply chain of a data, not at the very, very end when someone is on a prompt trying to do something nasty and something bad is happening. So let's go switch our hats. So right now we're talking from a platform engineer perspective. This is where you can define a global policy. There are different types of policies that we have shipped with. There are data contract promises policies, there are data retention policies, there are privacy policies. In this one, I'm going to focus on enforcing a contract policy. So imagine we have this no PII should go to any LLM. And as a platform engineer, I need to kind of codify that. This is not just a documentation or PowerPoint to tell other people. This is, I'm going to actually write what this means in code. And this is, in this example, I'm using a bespoke code. I'm just using plain Python. But if you have been in this space of detecting PII in data, there's a bunch of models, there's a bunch of open source tools that are very good at understanding it. But for the sake of this demo, um, imagine we have a very simple version of this, which is using regexes. And as a platform, oh, maybe this needs to get a bit smaller to fit in this screen. I'm gonna close this. So this is how I'm defining my policy as code. It is using Python. I'm defining a verification on Python, similar how to we did promises. In this example, I'm using a Snowflake as an example, but you can have multiple versions of this for different services. You can think of the same for Databricks or ADLS or S3. And it's pretty simple. Samples the data, looks at based on the regex and says, based on that, try to make a decision around if any of these things match. And based on that, make a decision around should it pass or should fail this policy. And now what we can do based on this, we can use the Nextdata to say, I want to create a global contract called ensure no PII. And here's the code for it. This is the Python file that we just created. And now it's registered. The policy as a computational policy, as code, is now registered globally at the Nextdata layer. Next, I have to kind of activate it. And this is where, if I come back to this slide, so I've defined my type, I've defined my promise, but I need to say, where does this apply? Is this a policy that gets applied to a domain? Is it at the data product level? Is it about the shape of a data? Is it about any product that has PII tag on it? Is it data that has these kind of filter names on it? And that's where we get to the activation. This is the part that I'm activating this policy, and I'm specifying a filter. In this example, I'm just using a very simple, like just do it for online sales, like this specific data product. But you can imagine this is a JQL query that you can openly define based on all the information of a data product that we have, based on inputs, models, outputs, transformation, shape of a data. And when I activate this, you see that it's getting applied to whatever that filter um, matches that filter. And as a result of it, so this is the online sales, for example. And if we go to this online sales product, we see that now it is saying, okay, I don't have this policy because it happens to have online sales, happens to have some PI data that's sending to LLMs on the output port. And because during the activation, we also specified the consequence. We said we have to stop it. It stopped the data product before even doing further actions. when we think about this, if I come back to this mode, so I defined a policy, I activated it, and you see that this is a shape of my mesh on the bottom picture, and you see some of the products are not applied, some of the products are green, they are compliance with this policy, they ran this code in their environment, and some of them failed, like the online sales one. And that's where we can have different consequences, and the product owner can now make a decision of what should I do here? Is this a conversation? Is it something I need to change on my code? This one is pretty clear, no PII. Remove all the PII and make sure you have a promise to ensure that on your data product. We also thought about, okay, how can we be more productive here? Like, is there a way that based on all the policies, we can get like a little bit of a co-pilot help to get started with this kind of things? And that's why the same MCP server, if we go to it, you can ask questions like this, like, you can say, make this data product compliant with all applicable policies. And because it can go and fetch all the policies that applies to the product that I'm right now working on, it can kind of do the same thing. Like you see, it's trying to find the different policies around it. This will, again, take a couple of minutes, and I have ran it this morning. You see that it runs through those, it runs through the activations and lists them. And based on those, pulls in that promise inside your data product as a starting point so that you can get like a starting point to ensure those policies. We built this, there are a couple of scenarios that this global computational policies can be very effective. Um, we saw an example of this on enforcing no PII going to LLM. We also have a lot of customers who are using it for ensuring consistent data quality across different scenarios. For example, imagine you are a platform team and you want to say anyone who is having customer data or party data needs to have this, make sure it's a harmonized version one. It's the version that the consumers can join together. And in order to enforce that, you can write a policy again to say, if you have a data product that has this kind of columns or this kind of data, you need to ensure these kind of policies get applied to it. And when you define them, these policies go to this Nextdata OS policy repository. Data products that are applicable to that, pull those down, evaluate them locally on their compute and storage, and take action. If they pass, everything good, data keeps getting promoted to the output ports. And if they don't pass, you're in the failure scenario that requires manual intervention. Um, so that was the second part of this talk. So we talked about enforcing quality. We talked about enforcing compliance for those qualities with a different hat as a platform engineer who wants some sort of consistency across different stacks. There's a question around, if we define a policy, can we add it to an agent card in the A2A and use it as a trust verification step? I see Jorg is answering that. That's a very interesting question. I haven't played with A2A, but we have an example in the MCP in the next section of the call, where we're talking about compliance, which it's the same thing applies to the MCP protocol. All right, let's move on to the third one. So we talk quality, compliance. What about complexity? And that has been our mantra since day one. Like, if you have been following modern data stack and like the complexities in the developer experience, there's a lineage tool and there's a catalog tool, there's a transformation tool, so many different tools that they need to talk to each other. Each of these products were built for something very specific, and they're good at that, but it's at the cost of the developer experience or the consumer experience to stitch all of these things together. That's what actually got birth to the idea of a data product, to flip it completely on its head and say, let's not do it that way. Let's do it around the domain. Everything about sales, everything about product or customer should be a product, regardless of what services it's being using underneath. And now and when we did this, most of the boxes on the left was BI and ML. So we usually had products that had a port for on object store for parquets and historical data for ML, and we had a port for snowflakes and BigQuery and SQL compatible, mostly for analytics and BI. In the recent past 6, 7 months, when we talk to our customers, a lot of need is around now other ports that are specific to these kind of agents. And the same rules apply. So I want, I want to build an agent, and agents, the cool thing about them, help the end user to achieve a goal. So in this case, the end user wants to return the order. And agents, the coolest part about agents is tools and being able to call different tooling. And what we have found is when you're building agents for different use cases, you need the same data in different shapes. For some use cases, even internally, when we are building our own MCP tools and our own Nextdata AI, which helps you migrate from brownfield application and ETL, sometimes the data needs to be in MD files is fine. Sometimes it needs to be in a graph database. Sometimes it needs to have a specific answers to specific questions. So the question became, how can agent get the right modality faster? So as a platform team, you can enable these initiatives that want the same semantic in different models. And if we zoom in a bit, and we have kind of covered it already, but the product has defined semantics. So this is an example of a semantic on top on sales data. This customer ordered this. It has links to other models. We saw an example of this when we were looking at this data product. We saw these models, like these are definition of those things. These are the links to the where this data is coming from at the column level lineage and also from a semantic meaning. These are the same columns across different domains. And now we used to have these kind of views, like we used to have tables and views and objects. And for BI and ML, the interaction was actually very simple. You come to a data product, you look at the API and say, give me a connection. And for these ones, we give you a connection to the underlying JDBC. And for these ones, we give you a signed URL to access the object storage. And now we see tools require almost similar scenario when you need the connection, but the modality has changed. So we have graphs and vector embeddings. So when we were looking at this example a couple of minutes ago, you see that multi-channel sales provides the raw data and unstructured data on ADLS. It also provides it through Llama index as a structured data, but it also has it as a vector embedding in Pinecone. So if you're building a RAG application, you can also get a connection here to the Pinecone database and send it a RAG query to get contextual answer about sales data. But it didn't stop here. It's these categories, a consumer or an agent would go to the data product and ask for, give me a connection. You see, these are the actual connection that you're getting to the underlying storage. What we saw after was that with the rise of MCP tools and being able to take actions and the concept of too much context, too little context, and context rot, we needed to kind of give domains and data product producers some sort of a help and tooling in creating answer specific questions. And that got it got birthed to this kind of concepts around the same semantic is now available over API. So you can just go to a GraphQL API or REST API and ask a specific question. And the equivalent of that in the agent world would be an MCP endpoint to get latest customer. So in this example, when we had this data product, for example, that for the sales, multi-sales channel, you see under here now, it also has an API output with the MCP API for get total quantity sold by channel as an endpoint. And if I switch to my to any of MCP client and say, if I copy it from here, get total sales by channel, this client is configured to that data product. Jörg also talked a little bit about how we can do mesh discovery. I'm not going to cover that here. Now it's connected. It says, which one do you want? So I can say this one for online. So imagine this is going to be your Llama index in practice. This is just for test, but in practice, it's going to be your whatever agent tooling that you're using for building agents, connection to the MCP to get these kind of calls. And if I allow this once, you see that it's doing a request to that endpoint and getting getting the specific response, which helps the agents to be able to two things. First, hey, sales domain, what kind of questions should I ask? What are the kind of questions that I can get, that I can ask? And also, when the workflow finishes in the tooling part, it can actually call the function and get the specific results. To the question before about protocols, so the same rules around policies and promises apply here. You can, all of these promises that this product has defined around decision readiness, schema management, the same thing can apply to this one. That this MCP endpoint has to pass all this data quality before the data gets promoted for this endpoint to read the data from. Because if you think about it, this MCP API is just an API on top of a canonical data that has already passed all those checks. And as a byproduct of that, the same thing will happen when you are defining policies. There's no policy for this product, but if you had policies for this product, you can also enforce those kind of things on here. That these kind of promises and checks and validations had to be passed before any agent can call this MCP endpoint. Let's bring it all together. So we talked about three things. The first thing we talked about was enforcing quality. We talked about data product contracts and how are they different from data testing and data observability and how we're balancing those two. We talked about the rise of unstructured data and how with the unified interface, you can manage both of them in the scope of data products. You can read unstructured, serve structured, or even for some use cases, if your downstream teams need unstructured, serve unstructured, with the boundary of a product so that it has all of the quality and the schemas and data promises included. We talked a little bit about consumer-driven contracts, which is a data application development concept that we are still in here, which is it's hard to start from a blank canvas, look at my downstream usage patterns, and give me some starting points around what are the profiles of a data that I should be putting in my SLAs to help data teams provide the SLA faster. We also wipe code some contracts. So we asked Claude to generate one based on those consumers and kind of gave us a starting point, not 100% there, but 80% there as a starting point. That was the first item. We talked also about how to do compliance. We introduced the global policies as code. You define at the global level, you define a filter and criteria, and then you see it apply to your mesh. You see it how different domains that are applicable for that data quality compliance react to that. And as a platform owner, now you have more leverage in your toolbox to say, these kind of products should be stopped. These are warning. These are okay. As an incentivization tool to ensure the consistency that you want to see from different domain teams. And the last thing that we talked about is about containing the complexity. Let's reduce the number of duplicate ungoverned pipelines that we are building. What we're seeing without the boundary of the data product around this concept, what will happen in practice is we have a separate team, separate working on unstructured data, another place for serving it for ML use cases, another place for serving it for BI analytic use cases. And most of the time, this is the same semantic data that requires the same data qualities, or at least very adjusted data quality rules. So reduce the complexity by packaging it as data product and using the multimodality to reduce that concept. Or we actually didn't cover this, but you can also wipe code this kind of multimodality through the cloud code. You can actually ask. I think I have an example of this here. If I go to here, cloud. You can say, yeah, something like this, like create a data product from Amazon reviews. So this is a website that hosts Amazon review files as JSON files. And put it in detailed domain, put default vector embedding and default MCP endpoints. And surprisingly, with the addition of the MCP tool that we have shipped with this cloud, it actually does a very good job. It looks at the data, it kind of understands it, it looks at the schema files, based on that, suggest your models and suggest your semantic links and data quality. And it's like it gets you 80% there to kind of vibe code your way through creation of a data products because sometimes when you're new to this and you look at the code that of the DSL that we talked about, however, we try to make it very simple, it might be a little bit daunting to get started. Like, how do I define my inputs? How do I define my outputs? We have in the past we have created like user interface wizards for it. We have created YAML structures for it to make it simpler for domain teams. But then we are now finding it's much easier to give your marketing team some version of this so that we can get it started. We also package this with our own co-pilot experience called Nextdata AI to make it a little bit nicer to interact with and easier for less techy, less tech savvy audiences in domains to be able to ship them. That is the last part that I wanted to talk about. If I come back to this, what else do I have? Oh yeah, so we covered a lot of ground. I went fast in a bunch of sections. These are two links if you want to go deeper. There's a link if you want. This just goes to Calendly, which you can book time with us, or you can do this one, which takes you to a forum and you can put your information and use cases, and we'll get back to you. And that is the last piece. What else do we have in the questions?
Yeah. First of all, thank you, Sina. That was super interesting, and I think also like relevant for all of us. I think with this entire rise of Gen AI, kind of safety, just looking at like the first iterations of the MCP protocol, for example, I feel it's coming like a bit as a secondary start, and I think just to keep it safe and scalable, we need to make safe consumption of data like one of our first concerns before we roll anything out there in production, because otherwise we'll be hit pretty harshly, either with even fines if it comes hard, but often otherwise also in the lose of the trust of our customers. Um, in terms of questions across the different channels, let me just quickly double check here. One question is, what are the typical policies you're seeing in reality? So what are our, yeah,
Yeah,
customers, for example, interested in?
we covered on it a little bit, but we see right now as a platform owner, you don't have any leverage around data quality. It's up to producers if they do it or do not do it. So the main use case of policy that we see is trying to get some sort of a consensus or alignment or homogeneity around how different teams talk about the data quality and how to enforce it. So a typical example from a retailer is if your data product publishes information about product ID, it needs to be the harmonized product ID and it needs to have 80% completeness. If it doesn't have it, and the reason they were so excited about it was because people would spend days and weeks getting access to it, playing around with it, and then realize, this is not a good scenario for the use case. So as a platform owner, what they did was they defined a different version of this policy that we talked about, where instead of like a no PII, it was um, enforce 80% completeness on product ID. And as a result, almost every single data product in the organization failed because of that, because none of them actually
Mm,
satisfied that
yeah.
rule, and it created a bunch of like a reaction pool, healthy push and pull around. Is it 80%? Is it 90%? Is it 70%? And then that created a healthy conversation. That's the other example that we keep seeing.
Okay, cool. Um, Another question here. We're on a Databricks platform using Unity. What are we missing? What would this add in addition?
It's a good question. So when we think about the role of Unity, um, 2 points. Point number one, most of the examples here I use DuckDB and Snowflake and ADLS, but the same thing applies for Databricks. You have connectors to it. A data product can run on Databricks also. But specifically on Unity, the thing that Unity does very well is around, it's a very good place that has unification for all the table formats. And a data product, it's a very good place for it to store the ice. So if you imagine in your example, if you have, if I go back to this example, you can have this kind of iceberg output ports that
Mm,
you may use Unity. as the table format storage for those tables. The thing that we think is missing from table format catalogs and also business catalogs like Colibras um, and data hubs of the world. Um, Most of them, you're either crawling everything and trying to represent it with some manual intervention to make it a more marketplace, or you're a much lower layer similar to Unity as an iceberg or a
Mhm.
delta catalog, which doesn't have the proper controls around boundary of a domain. So most of the things that we talked today about inputs and expectations and outputs and contracts and policies are only possible if you can define that boundary around the domain and flip it other side, that the storage is just implementation detail,
Mhm.
the compute is also implementation detail. Let's push them down, have a data product first, domain semantic first representation. But yeah,
Cool.
we have customers who are on
Mhm.
Databricks and Unity too, and we think Nextdata is a great complement to build data products on top of Databricks.
Cool. With that, I think that's actually a good point to wrap up. Again, Sina, thank you so much for the presentation on this topic. If you have any follow-up questions, there's the links Sina shared just a second ago. Feel free to get in touch with us. You can also just go to nextdata.com. As mentioned, we'll share the recording of this as soon as it's done processing. And yeah, please keep questions and feedback coming. Thanks a lot.
Thank you. Thank you all for your time. Talk soon.